people. Hey guys, just gonna go do a quick bio break. We'll get started in a few minutes. Okay, let's get started. So I was hoping today to do a review of the new Web v2 native wallet code and essentially explain how we've improved security over our previous beta platform and explain how that keeps your money safe and all that stuff, as well as how we help resist some of the attacks like the earlier higher profile one that Willie was mentioning. The key aspect to our whole enterprise is building a front end to let users interact with their coins. And we would prefer that people have hardware wallets all the time. Unfortunately, that's not a thing that we can force everyone to do, and we're pretty much always going to have a software wallet fallback. The ideal thing is to make that software wallet fallback the best it can possibly be and resist the most attacks that it can. So that's what we tried to do. Now, I'll be taking questions, throughout the session because, I'm deep in this, and, I want, if you have a particular concern or, a theoretical attack that you'd like to hear, how could this guy, attack me? What do we do to resist, particular intrusions? Speak up and let me know, and I'll address those. Okay, so the first and the most key difference between our traditional beta platform and the new Web v2 platform is that the Web v2 platform stores everything on the client side. There's no server involved. In the beta.shapeshift.com platform, where it's a non-custodial platform because your keys aren't accessible to anyone else without your password, but there is an encrypted backup of your keys that's saved to the server. And when you log in on a different device, your ShapeShift account password is used to decrypt those keys and retrieve the seed phrase that lets you, sign transactions. In our new Web v2 platform, there's no centralized service to store that sort of information. And we can't just put it out to the world because some people use terrible passwords. And computers guess passwords a lot better than people do. So even things that people might intuitively, think are safe would not be safe to expose to potential attackers like that. So what we did is we changed the architecture, and now all of your keys are stored on your device and they don't leave your device. I think that that is the biggest single security improvement. Previously, a malicious ShapeShift employee cannot steal your coins, but a malicious ShapeShift employee could take, if they had access to the particular system that's super locked down that has the encrypted wallet backups, they could try a bunch of different passwords. In the new system, there's no data cache anywhere. There's no mother lode to get into. Another significant security improvement is that we now do password stretching or key stretching on the password that you use to sign into your native wallet. If you have, so if you go to app.shapeshift.com right now, you may notice that the page sort of freezes for about a second when you log into your native wallet. The second delay is on purpose. The screen freezing is an interim thing that we're going to take care of, and it's just haven't had time to fix that yet. But the 1 second delay is built in, and in fact, the first time you load the page, there's a benchmark that runs on your computer or in your web browser to calculate how many cycles it has to go through to waste 1 second. And that ensures that if an attacker is trying to guess your password, it will take at least 1 second for every password they're trying to guess. And that takes the number of things that they can guess from millions per second down to 1 per second, and is significant improvement. The final and I guess the new component of the security solution is that the key material is not just your password. So in the beta.shapeshift.com, your password protected your seed. And if somebody knew your password, they could get your seed. In app.shapeshift.com, someone not only has to have your password, but also have access to a thing called the machine seed. The machine seed is a random 32-byte number. It's generated the first time you load the application and stored in the IndexedDB storage in your web browser. And that is used to derive the key for the vault. The key for the vault, the machine seed cannot be exported from the browser. There's this fancy thing called subtle crypto and web crypto, and it's pretty cool. One of the things it does is let you generate encryption keys on the web and use them and flag them so that the browser will never let anyone see them. And that, if someone was able to export the machine seed, well, they could take that and your encrypted vault and go offline and, get a whole bunch of GPUs or something from, crypto miners or something and burn through all the passwords on the list and try them. But because that machine seed is flagged, it's created with the non-exportable flag. It never leaves the browser's storage. Ordinary attackers are unable to exfiltrate that key. And every guess that they perform has to be done on your machine, on the app.shapeshift.com site, with the tab open somewhere. and probably in the foreground, because if it's not in the foreground, the browser will throttle you hard when it figures that you're trying to mine Bitcoin in the background or something. The I guess at this point it's smart to talk about threat models, because the primary threat model that we're trying to defend against is a cross-site scripting attack, which I don't know. I don't actually like that name because it's not super descriptive. Basically, it's code injection. Okay, you hear XSS, read code injection. The security model for the web assumes that anything delivered from a particular website has full access to everything that website stores. So any code that can run from, say, app.shapeshift.com can access any of the resources that app.shapeshift.com has. And that includes things like the machine seed. So if a malicious person were able to trick app.shapeshift.com into loading something malicious, or if they were able to convince a user, to press some button or enter some code somewhere or something that could run as app.shapeshift.com, then they would start to be able to guess those passwords, at the rate of 1 per second. If the attacker is another website or somebody that's not on your computer, that's all they can do. However, hardware wallets are still superior. And one of the reasons for that is that they resist more types of attack. There's nothing you can do in a website to prevent the browser itself from seeing key information. And that applies not just to, if your browser is made by, I guess, if you ran some weird fly-by-night vet browser that some weird guy compiled for you, then sure, it might be hacked. But more importantly, anybody that's hacked your computer can see all of the stuff that your browser can too. The keys are flagged as non-exportable, but on disk, they're just stored, next to everything else with a little flag that says they're non-exportable. So if somebody hacks your computer, then they can get that machine seed and start guessing passwords for your native vault. They still have to have your password, but they can guess fast. The key stretching will still protect you, but maybe they go offline and try a computer that's way faster than yours. And, instead of a second delay each time, it's only, a tenth of a second, something like that. So Ron has asked a good question here. The stuff about how does this all work on mobile? And I'm glad he clarified he's talking about WebV2 mobile, because none of this stuff has made it to the mobile app yet, because the mobile app is still, tied to the legacy system at the moment. And the goal is to replace it with WebV2 mobile. And that probably looks like an app that is more or less a wrapper around the current WebV2 mobile website, but it would be cache first, and it would be offline first, and it would also have even better protection in its final form. But even as it is now, if you go to the WebV2 interface on mobile, it will generate a machine seed. It will store it using the browser's IndexedDB API. The browser supports web crypto, and it will do, you'll get all the same protections on mobile, or the entire thing will explode. So that's the goal, right? Like that's the innovation of digital systems. It either works or it doesn't. There's nothing in between. And if your browser on mobile is new enough to support, the stuff, which, all reasonably new browsers on mobile are, but I do have a Windows Phone 7 in, like a box somewhere that I'm sure it wouldn't work on, for example. But in that case, you won't get into a weird, like half secure situation. You just won't be able to use the website at all. You won't be able to set up a native wallet. We're also working, by the way, on MetaMask support for the WebV2 on mobile. MetaMask has its own browser in mobile, and it's a little tricky to integrate with that because of exactly how they inject some of their code and whatnot. But that would also be a secure solution, with the caveat that MetaMask is always and forever just going to be an Ethereum only thing. So, your native wallet on WebV2 covers every chain. But if you do link it with MetaMask, then that's great. But Ethereum forever. So anyway, let's see. But still, with the we take a lot of care with who has access to that seed. But even if someone can't steal your seed, they can still cause you a bad time, because sometimes people ask, why don't you use a standard bug scoring method for your assigning bounties for your responsible disclosure program? The primary reason is that there isn't really a good one for crypto stuff, and that is because confidentiality breaches and authentication breaches, integrity breaches, are basically the same thing in the crypto space. Disclosing your seed is just as bad as accidentally signing a transaction that sends all your money to an attacker. So there's two prongs to the security. First, prevent the attacker from learning the secret information. Second, prevent the attacker from being able to run any code on the website at all. In order to, if you resist XSS attacks, then you resist an attacker being able to, just ask your wallet, please make a transaction and send all your money to me. That's not exactly the particular threat vector that the approval attack that Willie was talking about earlier today is. It's not a direct send of funds. It's an approval of funds that are then pulled later to sort of obfuscate where the problem is. But at the end of the day, those funds got stolen because somebody signed a transaction that said the attacker can steal my funds. And they did that because the attacker convinced the interface to do it for them. Resisting those kinds of attacks is a high priority it's a high priority for everybody, but we put in extra design effort to make that very difficult in WebV2. One of those things is a thing called the content security policy. It's basically a whitelist of all the stuff that can be connected to or load scripts on the WebV2 platform. You can see that content security policy in it's delivered two ways. It's delivered via a meta tag and via an HTTP header. So if you go to view source, if we don't have that anymore, let me just check it and see what we've got in prod right now. If it's not showing the meta tag on prod in the moment, yeah, okay, whatever. There's a bug. It's going to be, there's a fix is already in. It'll be merged later, and you're not insecure. It's fine, but whatever. So if you pull open the network tab and look at the content security policy header, then you can see the specific whitelist of stuff that is enabled for the WebV2 platform to talk to. I'm going to share my screen on the vault on the web repo here, so I can just show you the list. Zoom, screen, web, there we go. I've been doing some diagnostic work with Pindo, tracking down, exactly what it connects to and if they're, living up to the security claims that they've made. And so I've got some, commented out Pindo stuff in here. But this is the list. This is everything that the website is allowed to connect to. That involves a few external APIs. These are mostly for metadata about tokens, like icons, information about which Yearn vaults are available, and current APRs and stuff like that, as well as our unchained nodes that actually serve the chain data that you're looking for. There's also an Infura instance that's this Ethereum node URL that's used for the Yearn stuff. But if anyone tries to inject code, it has to come from something in this list, or it won't work. There are a couple places we can get a little tighter on that. There's a couple of legacy things that require a looser script source than I would like. The unsafe inline stuff, there's already a PR out to fix that. The unsafe eval stuff requires a couple of version bumps in a couple of downstream library or upstream libraries, and again, we're working on that. It's getting better. But even these settings will protect you against most things. The reason for that is that in order to take advantage of either of these things that's tagged unsafe, you already have to have a foothold on the page. So if you're not, you can't inject a script into the page if it doesn't come from one of the sources on this list, and that massively complicates an attacker's life, essentially. The list here also controls any target location that the attacker can use to exfiltrate data. So you can see I had to enter specific Pindo URLs into the configuration here in order to allow the Pindo client to talk to the Pindo servers. By default, the Pindo configuration, even without any special security stuff, if you just inject the Pindo script, by default, the content security policy locks the entire thing out and prevents any data from being sent externally, which is exactly what it's supposed to do. And Pindo is an analytics provider, and if you think about it, that's basically the same thing that an attacker wants to do: send a bunch of data out of your page. So it should prevent the thing without you putting it on the whitelist. So I would say that the ShapeShift Web v2 app is probably one of the most secure front ends that for Web3, web-based coin interactions that I know of. If you're paranoid, don't use a web app. You can download all this source code and run it off your computer if you want. You can run it on you're going to need an unchained proxy or something. But if you're super paranoid, don't put your keys online at all. Keep them on an air-gapped machine. But if you're looking for a first-class, nice GUI, all-in-one experience, there's not really anybody that does it better than we do. I mean, that's a little bit of bragging, but I think it's justified in this case. Had the XSS attack on the approvals, if they'd had a content security policy that was locked down sufficiently, they probably wouldn't have had a problem. Had they had some of the stuff we plan for the future, they definitely wouldn't have had a problem. This is this is what we have right now, and I'd love to field any questions that people might have on that. But there's also lots of cool things that we plan for the future that sort of is a natural extension of this feature set that I'd love to talk about too if people are interested. So the key innovation, I guess, of this. Let me show you the vault architecture that all this stuff is stored in. Switch my screen share here. Yeah, here's all the super scary code behind the keeping your stuff safe. This is all in our HD wallet repository. It's all open source. You can go look at it and find where we made bugs, and fix them if you want. But the key thing is that there's this encapsulated notion of a vault, and a vault holds your native keys. It looks like that to the rest of the world. All it has is a bunch of stuff. It is a map that can be looked up. You can store arbitrary stuff in it. You can store keys. You can store transaction history. You can store whatever, and all of the security is wrapped up in this interface. Yeah, Ron, you have a meta question, and you raised your hand. Sorry, there we go. Please give me audience interaction. So my personal perspective is I think the defenders are at an advantage. And that sort of differs with a lot of people's interpretations. A lot of people say the defenders have to cover a large, attack surface, and the attackers only have to succeed in one place. And that is true. However, the defenders also get to control the rules of the game in many cases. Sure, if you're trying to wrap security around a legacy system, that becomes a serious problem. If somebody is not building with security in mind, and they build a system that has a lot of attack surface, then defending that attack surface will become very hard. But if, on the other hand, you build for security and make sure that everything you do is extremely minimal, you're in a much better place. The other thing is that you get to, if you hold your secrets, as a defender, I can make the product less usable in order to increase security. Okay, the attacker cannot do that. That's sort of the fundamental difference. That is not something that we want to do, but it's sort of I think it puts us at an advantage because we can make strategic decisions. For example, we can decide we're not going to put all of the data on a central server, and that just completely changes the game. A lot of the traditional assumptions that have been made about how applications have to be written are driven by sort of enterprise use cases or enterprise high quality traditional software development practices. And a lot of those are focused around extracting the maximum value for the software manufacturer. Whereas, as a security guy, I'm focused on ensuring the security of the user. And being in an environment where people are willing to, make changes to the code that are fundamental in order to increase security, that's a very valuable one. I will say that there is sort of an element of the Wild West in the fact that we're programming in JavaScript in the first place, because uh, the web is like a super weird platform. Um, it's the accumulation of many, many years of weird backwards compatibility hacks. And essentially, until fairly recently, the tools to do something securely weren't easily available. There are still tools that I would, that we just don't have access to on the web, that would be, like hardware security devices, that would be very nice to have. But I do think we're in a position where, we can start to outpace the attackers. We have content security policy. We have web crypto. We can set up isolated origins for different things and post messages between them. This is stuff that wouldn't have been possible, say, 4 years ago, but is now widely supported enough by enough browsers to enable us to do something like this. It is possible to build software with no bugs. It's just very difficult um, to do that. I mean, actually, it's not hard to build software with no bugs. All you have to do is write a hello world program. That will have no bugs. That's not exploitable, but it doesn't do anything useful either. The trick is uh, making sure that you what you are trying to do, what you're trying to secure, is a very small thing, a very, very specific, well documented, well understood functionality. If you can isolate what you have to secure to a very small piece, then that really helps. Um, the attacker has a lot of it, a lot of advantages, primarily because people are generally bad at developing software. And the attack surface that is left open is usually big. Uh, if you make it as if you can reduce that attack surface, it is possible that you can leave an attacker with unable to find a way in. It's just very difficult to do so. Still, I think it's worth striving for. The sort of game theory stuff comes in when you have very complex applications. There's still a bit of it in terms of like who's got the incentives to do what. I think that having a bug bounty program can go a long way to that, for example, because if you have if you're paying people to bang on your stuff for you, and there's less people banging on the stuff for the enemy, and you're more likely to find the low-hanging fruit, because of sort of convergent goals between your white hats and your black hats. Anyway, I hope that answers your question. I saw Neverwas had a question. So I sent him an invite, but that's okay. Let's see. So some of the future stuff that we plan here is that now that we've, oh, hey, see ya. You got up here. That's cool.
Yeah, sorry about that, guys. Someone came to the door and the dog almost like ripped the door off the hinges. So, apologize.
That
um,
would increase your attack surface significantly.
oh yeah, right. um, yeah. So I just was commenting. Mr. Nerdhard, you have some great, um, points and stuff like that, and I definitely, would agree. JavaScript's been around. It's, not the most secure language, but it's definitely widely supported and available. a lot of the attack vectors, are kind of well known and documented at this point. So, you being able to approach it from that defensive stance of being able to, going in knowing what a lot of the risk is and being able to prepare and deal with that and block that is very helpful. And obviously, you like you said are building security minded first, which is my preference as well. It's not always easy to get um, engineers and everyone to sign off on that because sometimes it can be a little bit more work doing it that way. But I'm very happy when I see you in there all the time,
I've just
pushing
been
for.
very, very happy to work with this team, honestly, because like it's never really felt like a fight to me, to get people to do the secure thing. I mean, sure, people are annoyed sometimes, and sometimes, I'm wrong about a thing too, and the trade-offs are actually, you need to go in favor of usability or whatever. But the everybody, I think probably the fact that we're in DeFi, and that it's the engineers' money too. If the engineers ever want to use the platform, it's going to have to be secure. And as I think the incentives are well aligned on that, and I enjoy working in that kind of an environment.
Yeah, yeah, it's a huge advantage. I mean, coming from any coding environments that weren't that much involved with the own security of the project, like you were saying, you have a lot larger lapses, and that's why when you said that usually coders are not not this example, but coders can be lazy. They can take shortcuts. They can put things together after the fact, new features and stuff, and it can be very dangerous environment. So yeah, I've been very happy with what I've seen here. The presence and the mindfulness to be able to incorporate security first options. So yeah, I just wanted to jump up. Thank you, thank the team, thank everyone because a lot of these things really go unnoticed. Like when you did the CSP headers and stuff like that. That's stuff that I have always been mindful of whenever I've developed web platforms or anything. And to see you really jump into that and delve into that and ensure that that was in place um, made me feel a lot better as a user of the platform and someone involved. So thank you.
Well, thank you. I appreciate that. The CSP is sort of a thankless job because it always breaks everything. Once you got it in place, like I really should have budgeted more time for getting it working. This for Web v2, but the the great news about it now is it's in there and it will break fast when somebody tries to add a new feature. Like it'll be really obvious to them that they need to update the CSP to include whatever thing they're using,
Hmm.
and that will now that we've achieved that level of security, it'll be a lot easier to maintain it. Uh, like we have a CSP on beta.shapeshift.com, but it's stupid. I mean, like it's there. It's technically better than nothing, but it's got a lot of allow everythings, because it was put in after, you know, the thing was actually running.
Yep.
And getting it in on the ground floor with sort of a minimum lovable product has really helped. I think it'll set the lay a foundation for a good future.
Yeah,
Um,
no, definitely, definitely. Like I've done the grading, the testing of the beta dot shapeshift, and the score is like maybe like a C or something
no,
around that
yeah,
nature.
yeah.
Yeah, where
And
I
of course, that's what
definitely.
everyone does. Like, half the reports you get from responsible disclosure program are people who ran it through that and are like, your headers aren't right. And I'm going to be very happy not to have to explain to people, it doesn't count in this circumstance for these reasons or whatever. Uh, or this is a decision that's been done on purpose, or that's not fun.
No, definitely. Yeah, and I watch the PRs. That's something that like I can help with in the future, obviously. But I see you handling it and handling it very well. So I'm just happy that that security first mindset is in place.
So let me talk a little bit about the future of the native vault as I see it, and obviously we don't have prototypes for all this stuff yet, but hopefully it'll it'll be exciting from a security perspective as well. The current implementation has the master seed stored at app.shapeshift.com. But there is a really cool thing that we could use in order to avoid the possibility that app.shapeshift.com becomes compromised, or somebody commits some broken code, or that it's hackable or whatever. And that's IPFS. IPFS, I'm sure you all know about it. It's a immutable file system essentially, and the important piece is that Cloudflare runs a public IPFS gateway. You can go to an IPFS content hash dot cloudflare-ipfs.link or something, whatever it is. I know their ENS one is at eth.link, but that's also based on IPFS. But if you do that, you will get the contents of IPFS loaded. And importantly, that subdomain forms part of the origin for the same origin policy that your browser enforces. So if you store a key, if you have a particular version of code that corresponds to a particular IPFS hash and you load that subdomain, any keys it stores will only ever be accessible by that same code, assuming that Cloudflare doesn't screw you and return the wrong stuff for that page. Of course, if Cloudflare screws you, then you've got bigger problems, because they can override app.shapeshift.com because it's delivered through their service. They have a CA certificate and can sign anything to attack anything on the web. That's a little scary, honestly, but whatever. I guess we just all have to trust Cloudflare because their CA is built into every web browser, every mobile device, all of the things. And that's a fundamental limitation of the web model, but at least as it's implemented today. But if you do make the assumption that you can trust Cloudflare's IPFS bridge to not lie to you, then the browser can take advantage of that IPFS bridge to tie keys not just to origins, i.e. to some company somewhere, but to a particular piece of code. And the setup and the architecture work we've done so far in enabling the native wallet to be handled securely like it is will also allow us to have that native wallet be stored at a completely different origin than app.shapeshift.com. I'm thinking something like wallet.shapeshift.eth.link or something like that. I mean, it doesn't have to be an ENS name. ENS names are just cool. But if you did that, then you could make sure that the code that accessed the actual secrets was extremely small, and you could have a higher level of confidence that that code was correct. And you could also do things like require, just imagine here, this would obviously take UI work to integrate it into the flow, but you could require that people hit a button that's on a different domain, essentially, in order to proceed with the transaction. Think about how keep key works, for example. You plug in your keep key and you want to make a transaction and it shows up on the keep key screen and you have to hit a button. Well, you could do the same thing, except instead of it popping up a message on a keep key, it would be a pop-up window from another website. And that other website would be wallet.shapeshift.eth.link. And unless you hit the yes button, it wouldn't sign the transaction. Well, in that case, even if app.shapeshift.com is completely evil and totally taken over, it still only has the ability to ask nicely for this other origin to please sign a transaction, and that other origin will get your authorization first, and you'll be able to if you trust that fixed set of code on that other origin, then you can trust that the thing that you're signing, the thing that you see on the screen matches what you're actually being asked to sign. That would be really cool. I I could see theoretically that being used to provide a wallet that could be logged into from multiple sites, not just app.shapeshift.com. But that's sort of a in the future thing. I don't know if that'll ever materialize, but it's cool to know it's possible. We're also working on hosting app.shapeshift.com itself on IPFS. That's the reason that we deliver the content security policy via meta tag, as well as via the header. Because to serve headers, you have to have a full web server or something that's configurable in that fashion, and that's not true on IPFS or on statically, just downloaded copies of files. So the meta tag ensures that even if you are trying to use the website offline or, well, I mean, obviously it's got to tuck to unchained, so not completely offline. But if you're trying to use it, the saved copy on your desktop or something, or if you're trying to use it from IPFS, maybe a local node that you host, you can install the IPFS desktop application and use that, or you can access it through a gateway or whatever. But the content security policy will make sure that app is at least almost as safe as the regular one with the full set of security headers that get served. There's a couple things you can't do there, like forbid iframing and stuff like that. Clickjacking attacks aren't that common or useful in the wild, I don't think, personally. But they are still something to make sure that you design for. But aside from that, everything else you can do with CSP, really. Let's see. Well, that's all I really had thought of talk about. From my side, I'd love to address any concerns any of y'all might have or questions or comments. Right now the bulk of my work involves reviewing code from Pendo and for the Yearn router stuff. Apparently, you can never trust that DeFi protocols write good code. That's always annoying. Nobody's really done a Yearn router yet in production, and it turns out that their code has a few bugs in it. We have to fix it, so we're going to do that and then pay for the audit for them, so that hopefully they'll like us from that. Hardware wallet stuff, Ron says. It does bring up I was going to mention that, but so hardware wallet stuff is cool. Like everybody should get a hardware wallet. That's my opinion. I use hardware wallet for my primary funds. I think I have like a Ethereum or a MetaMask hot wallet for tests. I have a couple of native ShapeShift wallets for tests mostly, because it's just to test. That's what I do, right? But the hardware wallets are really the smart thing to do. Now, what you want is a hardware wallet that can actually show you what you're signing, and that's the trick. Because, like, let's say that approval exploit was run against somebody with a ledger. Well, the ledger is going to show, do you want to sign the following gobbledygook? And you're going to be like, yes, because the computer told me to. And the problem is that you will have, that's no protection. On the other hand, if you had signed that using a keep key, you would have seen on the screen, do you want to approve this to that? And you would have at least had a fighting chance of checking to make sure that, you're actually calling the right thing and approving the right contract. You still have to be vigilant, but, at least you can do it. Never was made some comments about JavaScript not being a great, security first development experience, and that is absolutely true. Oh yeah, hey, by the way, if anybody wants to bone up on their weird, obscure JavaScript coding skills, there is a great game called HackMud. You have to know JavaScript to play it, but it is it's like this combination of code golf, hacking, post-apocalyptic cyberpunk terminal. Anyway, it's pretty cool. Go look it up. Hack Mud. It's like $10 on Steam. You write JavaScript to hack stuff. It's awesome. The and if I wrote a JavaScript engine in WASM and then loaded it in JavaScript so I could get around their character limits. That was fun. The JavaScript, one of the things you'll learn from playing that game is that having access to run JavaScript in a particular environment leads to a lot of interesting compromises. That game wouldn't be nearly as fun in any other language because you wouldn't be able to hack weird stuff. One of the solutions to that is to write your code in WASM instead. And you don't really write WASM, you write it in some other thing and then compile down to WASM. But WASM has a completely different execution model. You can actually write secure stuff with it, and at least following a few with a few caveats. If you handle it properly, then stuff that you run in WASM can be much more resistant to code injection or to secret leakage or things like that. There are a few caveats. You have to set things up right. But one of the things I'd like to see happen in the future is to see KeepKey get compiled down, the KeepKey firmware get compiled down to WASM, for example, or see some fundamental transaction parsing code, at least, that we use turned into WASM. It would make it run faster, but it would also mean that you could use that library, that WASM library, as sort of a source of trust to be able to say, okay, this thing that to check the transaction you're about to sign and make sure that it really matches the thing that the user thinks it is. We've done a lot of work over the past year to get ready for that sort of thing. Like, for example, HD Wallet Native. Not only is it able to sign by calling out to an external signing service, but it also passes the raw data that needs to be signed instead of the hash of the data that needs to be signed. That's a common problem with ECDSA. You can only sign 32-byte messages, and a lot of people pre-hash stuff, so you can't actually tell what they're asking you to sign. Rust is real. I see Ron was mentioning that Rust is very, very good for security, and it also has a good set of tools for transcompiling to WASM modules. So, if I were to start a project and I wanted it to be, run in WASM, I'd definitely pick Rust. And the KeepKey firmware, Rust is also great for systems programming. And I've got a beta branch, it's probably a little earlier than beta, but I have a rewrite of the KeepKey firmware in Rust that I'm working on. And yeah, it's been a few months, but we've been focused on WebV2. I hope to be able to get back to the KeepKey stuff at some point here, because it's not just useful for hardware wallet users. It seems like an awful neat synergy if we could turn that into something that's used with the native wallet too. I know nobody else does that, so nobody else has that sort of a security feature, and we're comfortable putting KeepKey code on people, firmware code on people's KeepKeys, and then having them keep it in the safe, and 10 years later it has to work. Well, one of the problems with web development is that it's very difficult to be sure, to commit to code over the long term, right? Well, what if you do lock your keys up to a particular IPFS origin and it only works with certain code, right? Well, if it's KeepKey firmware that you're locking it to, that served as a WASM blob from that origin, that's probably a much easier sell than locking it to some weird JavaScript crap that you compiled. Anyway, it's always fun to look at code blobs and figure out what's actually in them that you didn't know what was in. That was in there. There's in the app.shapeshift.com blobs. It turns out there's an entire Google Analytics client. we didn't include it, but one of our dependencies included it just in case we happen to use Google Analytics. That dependency, made by Google. I know that's a shock. It's like turned off. We don't use it. It never gets called, but it's in the bundle. Costs us about 50 kilobytes or something. There's also conversion tables for like Ukrainian currency and weird stuff that like you never would have expected. A lot of times people don't know what they're actually shipping. I'm continually shocked when you actually this is a particular JavaScript problem because of how deep the dependencies are, and it's just difficult to establish a root of trust, I guess, in that sort of environment. So content security policy is key because it means that your dependencies can't secretly exfiltrate stuff to other websites, and that Rust WASM stuff would be pretty awesome too because your WASM blob can't have those problems. It doesn't have internet access. It only has you can only do what you let it do, and that's pretty nice. Anyway, Firebomb makes a good point. Always back your crap up on steel or at least paper. Come on, people. Put it in a safe somewhere. It's also probably worth making a crypto inheritance plan. Like if you die, how do your kids or your wife get your crypto? That's probably something worth thinking about too, because they find those secret 12 words or whatever scrawled on your on the back of your whatever picture in a safe or something, that they don't actually know how to necessarily use crypto. So anyway, I know we're running up on time here, but I love talking with y'all. I hope that people have all sorts of fun additional questions, and I don't know, rambling for an hour every week and then people telling me they like it is crazy. I don't understand that. So I just tell people that regarding the crypto inheritance stuff, I basically just say, hey, you should just go talk to some people at ShapeShift. Go to the ShapeShift Discord, they'll sort you out. That's probably not a very professional plan, but anyway. Okay, I know the governance call is coming up, and I should probably go to that myself too. So yeah, in case of death, visit Discord. I will let y'all go, and thank y'all for coming.